Welcome to the Explainer. So, if your laptop is currently burning a hole in your lap, you are absolutely going to love this. Today, we're unpacking a concept that, honestly, it sounds like it was pulled straight out of a sci-fi novel, but it's actually a rigorously documented theoretical breakthrough. We're looking at the Ortiz-Inostroza photonic non-Nuremberg device. Invented by Luis Manuel Ortiz-Inostroza back on July 15, 2026, this is a completely revolutionary light-based computing concept. It literally reimagines what a computer can even be. We're talking about moving away from brittle chips and messy wires and towards a solid, natural-feeling object that literally thinks with light.
Okay, let's dive into this and outline our approach. We've got a 5-part roadmap today. First, beyond silicon and quantum. Second, anatomy of a thinking stone. Third, the geometry of thought. Fourth, 3 core configurations. And finally, applications for the future.
All right, starting with part 1, Beyond Silicon and Quantum, a New Computing Paradigm. To really appreciate this device, we have to look at the problems with what it's replacing. Let's be real. Standard chips today are essentially just hot plumbing for electrons. They rely on fragile silicon, they push electrons through microscopic switches, and they generate a massive amount of waste heat in the process. Plus, they completely separate the memory from the processing blocks. And what about current quantum chips? Will they require literally freezing absolute zero temperatures just to function? Contrast that fragile setup with the Ortiz-Inostroza paradigm. This new approach uses solid stone composites, it operates entirely at room temperature, and, most incredibly, it acts as a room temperature prism for waves of meaning, where the paths of light actually merge memory and processing into one continuous fabric. It's a total game changer. Now, what's really interesting here is that term non-Nuremberg. If that sounds to you like a sci-fi twist on traditional von Neumann computing, well, you hit the nail on the head. In a normal computer, your processor is over here and your memory is way over there. But this device completely rejects that old numbers push through silicon model. A non-Nuremberg architecture means processing and memory are not separate entities. The physical matter itself, the actual shape of the device, is an active participant in the thinking process. Moving on to part 2. Anatomy of a thinking stone, the materials. Let's actually build this device from the ground up, metaphorically speaking, to see exactly how it works layer by layer. Step 1 is the base. We start with super recognizable earth materials here. Slate gives the device its physical strength and controls vibrations, while shungite, which is a complex carbon, absorbs stray electromagnetic fields. It acts almost like protective tissue. Then, step 2 is the engine. Here, we introduce ultra-thin layers. Think atomic-level crystal sandwiches. We're talking graphene and molybdenum disulfide mixed with metals like magnesium and zinc. This specific layer carries super-fast signals, manages heat, and provides switchable regions that are highly sensitive to light. And finally, step 3, the surface. This is a pure diamond or diamond-like carbon layer. Diamond is absolutely crucial here because it moves heat effortlessly, and it can carry light with virtually zero loss. Which brings us to part 3, the geometry of thought, mapping the light. So, we've built our physical stone, but how do we actually get it to think? Well, the secret lies in the flower of life logic map. I want you to really picture this. A cold, precise purple or blue laser deliberately carving a beautiful, repeating pattern of intersecting circles directly into that top diamond surface. And this pattern isn't just for aesthetics. It's a literal, physical brain map carved right into the crystal. Every single carved line becomes a tunnel or a waveguide for light. Every intersection becomes a decision node where that light can split, combine, or be redirected. By just tweaking the thickness of those lines or their spacing, you actually change how the light behaves. You are effectively wiring a brain out of pure geometry. And this perfectly illustrates the completely fascinating concept of whale logic. See, normally you write software code and you run it on top of hardware, right? Not here. Here, the language model is literally the shape of the chip itself. Whale logic treats signal patterns like a language. Instead of just doing simple yes or no math, it processes traveling waves of meaning. The logic is baked directly into which paths exist in that flower of life pattern and exactly what materials sit at those intersections. The medium is the message, and the geometry itself is the software. Okay, part 4. 3 core configurations. Execution. So how do we arrange these incredible materials into actual executable devices? There are 3 distinct setups to compare. First up is the carbon slate engine. This is your foundational thinking stone. Signals move mostly as electrons and fields inside a dark carbon network, all guided by that Weyl logic. Next, we scale up to the graphene molybdenum core. This one is a flat, two-dimensional neuromorphic, basically brain-like, map, where the wiring layout handles the complex memory and logic. And finally, the ultimate execution, the diamond photonic device. This is the fully light-driven quantum thinking stone. Information comes in, turns into light, races through those diamond flower paths doing massive computations, and interacts with quantum defects, which are these tiny, intentional, perfect little flaws in the stone below. Finally, Part 5, Applications for the Future, the Payoff.
We've covered the what and the how. So, the crucial point is, what can a thinking stone actually do for us in the real world? Just imagine a piece of technology that doesn't just calculate, but actually feels its way through complex waves of data.
The applications here are absolutely staggering. On the highly technical side, we're looking at hardware-embedded AI. We're talking deep language understanding happening at the speed of light, built right into the stone itself. And because it computes with waves, it is absolutely perfect for complex scientific wave simulations, think climate modeling or mapping molecular structures. Plus, it can act as a quantum-secure communication hub, using single photons to create completely unhackable networks. It offers high-precision environmental sensing, and it totally revolutionizes energy and heat management. But then we get to the truly mind-bending stuff. Because it operates on waves and fields, this could literally be the key to seamless brain-machine interfaces. And on a purely artistic level, because it uses light and geometry, it could even be integrated into living architecture as interactive glowing art. Now, as amazing as all this sounds, we do have to keep grounded in reality. The source material outlines some pretty significant roadblocks. First off is the extreme manufacturing complexity. Combining slate, delicate graphene, and laser-carved diamond in a reproducible way, that goes way beyond what our current factory lines can handle. Second, there's a massive need for precise defect control. Remember, the entire system relies on tiny, perfect imperfections in the crystal. And finally, we just lack the design tools right now. Our current software is built for traditional chips, not for simulating a device where geometry, materials, and logic are intertwined to this degree.
But, these challenges really just mark the path for future research, because the ultimate vision here is so profound. To quote the source text directly, this device proposes a future where computers exist not as flat chips on boards, but as living stones of light and thought. Which leaves us with this final thought to ponder. If the future of computation moves away from cold, rigid metal and silicon and instead is built from natural stones, geometries, and light, how will that change our fundamental relationship with the machines we create? Will they feel less like tools and a lot more like partners? Thanks so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.